Gravity is the quiet architect of the cosmos, a force so familiar that we barely notice it in everyday life, yet so fundamental that without it, nothing in the universe would exist. It keeps your feet on the ground, guides the moon around the Earth, and orchestrates the motion of every planet, star, and galaxy. We often imagine gravity as something simple, an invisible pull, a downwards tug, a basic force that just keeps things together. But when scientists look deeper, gravity reveals itself as something far more profound and mysterious. It is not just the glue of the universe, it is its engine, its sculptor, and its hidden storyteller. To understand how gravity shaped the universe, we must begin at its beginning. Not just the beginning of stars or galaxies, but the beginning of space and time themselves. Right after the Big Bang, the universe was a chaotic, hot sea of particles, energy, and radiation. Gravity was incredibly weak compared to the other forces, trillions of times weaker than electromagnetism, but it had one advantage the others didn't. It works over infinite distances. That tiny seed of gravitational influence would eventually guide the formation of every structure larger than an atom. In the first fractions of a second after the Big Bang, the universe expanded faster than the speed of light in an event called inflation. Gravity didn't cause inflation, but it became the force that took over once the expansion slowed. The early universe wasn't perfectly smooth. Tiny quantum fluctuations caused slight differences in density. Some regions had a little more matter, some a little less. It was subtle, differences as small as 1 part in 100,000, but gravity amplified them. Wherever the density was slightly higher, gravity pulled in more particles. The rich became richer. Clumps became clouds. Clouds became the seeds of galaxies. In that sense, gravity was the universe's first amplifier, turning microscopic randomness into gigantic patterns. Without these early gravitational imbalances, the universe today would be nothing but a thin, cold fog of particles. No stars, no planets, no life. As the universe aged, gravity continued shaping everything. About a few 100 million years after the Big Bang, gravity pulled enough hydrogen and helium together to ignite the first stars. These stars were enormous, hundreds of times the mass of the Sun, and burned intensely. Gravity compressed them until nuclear fusion began. That fusion produced the first light in the darkness of space and forged heavier elements inside their cores. When those massive stars exploded as supernova, they spread those elements across space, planting the seeds for future stars, planets, and eventually life itself. Gravity was behind every stage of this story. Without it, no star would have collapsed, no fusion would have ignited, no heavy elements would exist. Everything we are, our bones, our blood, our planet, came from the work of gravity inside ancient stars. But gravity does more than build stars. It builds galaxies, the sprawling cities of the universe. Galaxies form when enormous clouds of matter collapse under gravity. These clouds rotate slightly, and as they collapse, rotation speeds up due to angular momentum. That's why galaxies form flat disks with spiral arms. Gravity pulls inward while rotation spreads material outward, creating a balanced, swirling structure. It's a cosmic tug-of-war with beautiful results. Over billions of years, galaxies merge and evolve. Gravity choreographs these collisions like a slow-motion dance lasting millions of years. Sometimes galaxies pass through each other, stripping gas, triggering waves of star formation, or even swallowing one another. Our own Milky Way is currently on a slow collision course with the Andromeda Galaxy. In about 4 billion years, the two will merge into a new galaxy, a monstrous glowing structure often nicknamed Milkdromeda. Gravity will guide every aspect of that transformation. But gravity's role goes even deeper. Modern physics explains gravity through Einstein's general relativity. Mass bends the fabric of spacetime, and objects move along the curves. This idea replaces the concept of forces pulling objects with space telling matter how to move. A planet orbits a star not because it is pulled by an invisible rope, but because the star has curved spacetime around itself. This curvature affects not just motion, but time itself. The stronger the gravity, the slower time flows. This has been measured on Earth. Time passes slightly slower near the ground than at the top of a mountain. In black holes, gravity becomes so intense that time nearly stops. These time wells are among the most extreme objects in the universe, where gravity shapes not just matter, but reality. Black holes might sound destructive, but they also play a surprising role in cosmic growth. At the centers of galaxies, supermassive black holes, millions or billions of times heavier than the Sun, influence the flow of gas and star formation. When matter falls into these black holes, jets of energy shoot out, heating surrounding gas and regulating how stars form. In a strange twist, black holes, the ultimate gravitational traps, help shape the life cycle of galaxies themselves. Their extreme gravity helps maintain the balance between creation and destruction. If gravity builds the universe, why is the universe expanding faster over time? Shouldn't gravity pull everything back together? This is one of the greatest mysteries in modern cosmology. Observations show that the universe isn't just expanding, it's speeding up. Something is pushing galaxies apart. Scientists call this force dark energy, though no one truly knows what it is. Gravity and dark energy appear to be in competition. Gravity gathers matter, dark energy spreads it apart. The future of the universe depends on which side wins. Yet even with dark energy, gravity remains central to everything that matters. It determines the life of stars, the shape of galaxies, the behavior of time, the formation of planets, and the possibility of life. It is the only force that acts on every particle in the universe. It cannot be shielded, blocked, or turned off. Even light, the fastest thing in the universe, bends around massive objects because gravity shapes the space that moves through. Gravity even affects life in ways we rarely consider. The strength of Earth's gravity influences biological evolution, from how tall trees grow to how strong our bones must be. Astronauts who spend months in microgravity lose bone density and muscle mass because their bodies evolved for 1G gravity. If humans ever live on Mars or the Moon, gravity will shape how future generations grow, move, and even look. Life is not just chemistry, it is anatomy shaped by gravity. The strange part, scientists still do not fully understand gravity. We can describe its effects with great precision, but we do not know exactly why gravity exists or how it fits with the quantum world. Quantum mechanics governs particles, general relativity governs gravity. But the two theories don't match, and a unified theory of quantum gravity remains one of the greatest unsolved problems in physics. Some theories suggest gravity may emerge from deeper principles such as information, entropy, or the holographic nature of spacetime itself. Others propose extra dimensions or particles called gravitons. We simply don't know. Gravity, the most familiar force in the universe, is also one of its deepest mysteries. And that is why scientists call gravity the hidden hero of cosmic evolution. Without it, the universe would have no structure, no stars, no planets, no galaxies, no time dilation, no black holes, and no life. With it, the universe grows, changes, and becomes more complex with every passing era.
Gravity is not just a pole, it is the architect of the cosmos, the composer of the cosmic symphony, the silent power that shaped everything we see. Every night sky, every sunrise, every planet, every star, all of it exists because gravity quietly did its job for 13.8 billion years. And in that silence, gravity continues to work sculpting the future of the universe, one falling atom at a time. Don't forget to like, share, and subscribe to WiseUse, where the universe becomes clearer one mystery at a time.